The next stop on the Voyager probe's grand tour of the solar system is Saturn. But the ringed planet is over 450 million miles away from Jupiter. To get there, the Voyagers will need to perform a maneuver known as a gravitational slingshot, which will catapult them from one planet to the next.
We allowed the large gravity of Jupiter to actually capture the spacecraft and start accelerating it toward that massive planet. But we did it at just the right angle, so we would move around it and then continue away from the planet. Jupiter itself is barreling around the sun at very fast velocities. As you pull away from Jupiter, you keep some of that velocity with you.
If it's successful, the slingshot will knock years off the Voyager's journey. If things go wrong, it's game over.
To do a gravitational slingshot, you need to do 3 things. You need to have really good calculations, excellent planning, and perfect timing.
Mission controllers achieve all 3, and the maneuver works. Voyagers 1 and 2 speed up by 22,500 miles an hour and race towards Saturn. 1980, right on schedule, Voyager 1 arrives at the ringed planet. Its sensors probe Saturn's atmosphere and discover it's mainly hydrogen and helium.
Saturn has nearly 100 times the mass of the Earth, but it has so much more volume that when you look at its density, it's actually less dense than water. There's a very old joke in astronomy that if you put Saturn in a bathtub, it would float, but it would leave a ring.
The most striking discovery emerges from the data 9 years after Voyager's flybys, a bizarre cloud formation at the North Pole.
A giant hexagon over the North Pole with sides 9,000 miles long and it's 18,000 miles across. Yeah, that's bizarre.
You don't often think about very stable geometric shapes like a hexagon. That feels like it shouldn't happen, right? You don't get hexagon-shaped clouds on the Earth.
What could possibly create a hexagon more than twice the size of Earth?
Voyager discovered the hexagon, but we didn't have enough information to truly understand it.
Jump forward 24 years after Voyager, and another probe arrives at Saturn, Cassini.
The main difference between the Cassini mission and the Voyager missions, besides Cassini having more cutting-edge equipment on it, is that it was an orbiter. It orbited Saturn for 13 years. The Voyager missions just flew past it.
Cassini watches the pole for several years, capturing thousands of images of the hexagon.
The beauty of the Cassini mission is that it showed us what the hexagon looked like years later after Voyager. It didn't necessarily solve the problem of why this thing exists, but it gave scientists a lot of ammunition to figure it out.
Finally, in 2020, a team solves the mystery. Many cyclones surround a large jet stream at the planet's North Pole. Where the 2 weather systems meet, a hexagon cloud forms. Something we don't see here on Earth.
The trouble with Earth is it has a lot going on. We have oceans, we have mountains, all of that disrupts the atmosphere. On Saturn, there isn't any of that. So you're able to have these very stable airflows. It just wouldn't be possible on the Earth. Nature's pretty wonderful.
Next, the Voyagers turned their gaze to Saturn's rings. Their images are game changers.
One of my colleagues in my undergraduate planetary astronomy class was a computer whiz, and he managed to hack into the NASA feed that was going out. We all piled into his dorm room, the professors, the students, seeing images coming from the Saturn flyby.
We thought that Saturn had just a handful of wide, flat rings. Voyager's images reveal thousands of separate rings orbiting the planet. But there's an even bigger surprise, an impossible ring.
When the F ring of Saturn a close-up image appeared on the screen. And instead of being sort of a single ring, it looked like multiple rings that were braided together. And my professor, Erwin Shapiro, famous planetary astronomer professor, said, "That's not possible."
Scientists pore over the images to figure out what's causing the bizarre structure.
Our basic understanding of rings back then was that they were collections of little particles that were all just following the same orbit.
You would expect that system to have settled out into, all the traffic on the highway driving in the same direction, parallel lanes, all nice and neat. And you don't expect these weird dynamic interactions that are going on.
Then, scientists find 2 clues to explain the interactions.
And one of the things that was discovered was 2 satellites that orbit inside and outside of the F-ring, Prometheus and Pandora. It pointed to the idea that the moons and the rings were constantly interacting, but it didn't really tell us how.
Voyager's discovery of the moons doesn't solve the mystery of the braided F-ring, but it does tell the Cassini probe, 25 years later, where to look. Cassini watches the tiny moons, looping and twisting around each other as they orbit the planet.
When you have 2 little moons sort of co-orbiting with the ring, there's a complex gravitational dance that happens with the inner moon wanting to speed up particles, the outer moon wanting to slow them down, and that interesting gravitational dance is what actually helps confine the ring into the narrow structure that we actually see.
By seeing these moons either side, there was an idea that they could be shepherding, they could be holding the ring in place.
Saturn's many moons and complicated rings are like a mini solar system. Now, the 2 Voyager spacecraft separate to carry out 2 individual missions. Voyager 1 heads off to explore the edge of the solar system, and Voyager 2 flies into the freezing cold of Saturn's shadow. For over 2 hours, the giant planet blocks all contact with the space probe. After a tense wait, Voyager 2 emerges. But something's wrong with the spacecraft.
Picture after picture of dark sky came back, and we realized something had either happened to the cameras or something had happened to the scan platform.
The scan platform, the vital rotating joint that points the probe's instruments, isn't working. But how can scientists fix a probe 2 billion miles from Earth?
The scan platform is kind of like your head and neck. Imagine the cameras as your eyes, and if you want to turn to look at something, you turn your head, and your neck has to move.
When Voyager 2 passed behind Saturn, it plowed through the rings at 29,000 miles an hour. Maybe a chunk of ice damaged the platform, or maybe the maneuver gave the probe whiplash.
We had been so ambitious in looking at the moons and the rings and Saturn that we had literally squeezed the lubricant out of the bearings of the scan platform, and it got stuck.
The broken scan platform could be fatal for the rest of the mission.
And so we worried, could we fix it? We had Uranus and Neptune ahead of us with Voyager 2. We wanted to be able to fix the scan platform.
To fix it, the engineers employ some space physiotherapy.
We slowly commanded it from Earth and got it to move a little bit at a time until finally we could get those beautiful outbound pictures of Saturn that you see.
With Voyager operational again, NASA agreed to fund the next stage of the mission.
I'm eternally grateful that NASA did decide to complete the grand tour.
There was tremendous relief to know we had a healthy spacecraft, Voyager 2, to go on to Uranus and Neptune.